Welcome back to week 3 of my effort into building PyFlow Studio. The app has moved a bit more ahead with a few features I have added. I spent a lot of my time trying to get to clean up the code and fix some niggly issues with some aspects of the app. But I've also added a few new things as well. So I would like to go through them now with you all, since you are probably interested in it. So support for boards has been implemented in a slightly different sort of UI UX way than how it was before. If you remember from my previous videos, you would have seen an indicator here or an information panel here, which represents or which presented information about the Pi that the app is connected to. Now that is gone. Instead, we have a settings page. In the settings page, we have a place to manage the list of boards that the app is going to interact with. The boards simply mean the Raspberry Pi boards. Now you are able to add new boards or manage them here, as well as test the connection to the board while you're setting it up. Now, what you see here is a list of boards with a specific name specific names attached to them. For example, fan board or switchboard. They are referencing boards that are connected to the network. Now, if you would look at the left of the screen, you would see a sort of a circuit arrangement there. Actually, there are two circuits isolated in the sense that there are no direct wire connections between them, but they are connected, not connected between each other, but they are both connected to the same home network that the app is running in as well. So that is typically your arrangement within your home automation systems, where all these devices connect to the same network at least. Now, what you see there is one Raspberry Pi connected to a fan, which I'm sure you can see here. The other Raspberry Pi connected to a switch and a light board here, right? So they are isolated, and we are going to be using formulas to interact with both of them, which means that we can listen on one board and act on the other board. So to achieve that, what we do within our formulas is to specify the board where you're reading or writing from. So for example, on the app startup, I would like both the fan pin and light pin to be switched off. So that I can then work with them when someone switches on or do some do some actions. Now, what you're seeing there is that from the previous videos, you might have seen that the right pin formula used to have just two parameters. So the first parameter being the pin, the second parameter being what level should you switch to set, whether it should be switched on or switched off. However, in the new, you can refer to the boards as well. You will have to refer to the boards actually. But to help you help it easier to make it easier for people who are using the app, we have a boards object. A boards object is a global object, which means that it's available to all formulas, but it references the name by its in real name. For example, I cannot basically go some other board and expect the formula to work. It won't, because some other board doesn't exist. So that way, the app helps you make sure that you're referencing boards that actually have been configured. Now, with that, what the app can now do is that it's not only can switch on or switch off a pin on a Raspberry Pi, but it can switch on and switch off a pin in different Raspberry Pi to which raise an event. For example, there is that GPIO flow that we were looking at last time, and you can see that the formula is pretty similar to how it was before, except for the fact that each of these right pin formulas refer to the board, which board they want to do. But there is also one change. The pin settings used to have just the pin to watch and the edge. Now there is a way to select the board that should be watched, which means that you can actually listen to the flows could listen to multiple boards and multiple pins in those boards if they need to. So let me explain what I mean. So if I were to press that button now, you can see that it has switched on the fan, and there is also the light that has been switched on. Both are in completely different circuits, which used to not happen in the last time. So let me switch that off again. So that is the new boards feature that I have been added. The second feature that has been added to the app is the concept of console views and console logs. The way it works is that you've got a console view, a page where you can see the messages that are coming back from the server. The server is in the background streaming messages, constantly from its, depending on what's happening in it. For example, if it's trying to interact with Raspberry Pi, it fails, and then it'll log an error. If it needs to give you more information about the fact that a flow failed or a flow is not running, it'll log an error. But not just that, you are able to then write to this console log the debug messages while your flows are running. For example, here is one where there are no messages running. So what I'm going to do is I'm going to basically write to log the fan was toggled, and then log it as a debug message. The fan, that means a toggle switch was pressed on, and log as a debug message. The second thing I can do, obviously I can copy that and paste it somewhere else, and add more messages. The fan was switched off. So both are logged as debug. You can actually log as different you can send different types of messages. For example, if you want to log an error, or if you want to just give write some information on there, etc. So I'm going to keep that to debug, and then we're going to publish that. Now, if I were to basically go into console and change that to debug, let's actually see what happens when we press that button, right? So let's press that button. It should work normally. But if I go to console and if I go into debug, you should see that the message comes up here. Now you can log as many messages as you want, obviously. So let me switch that off again. So that is the console view. There is also one setting that we have added, which allows you to specify the default view that you want to see when the console log starts up. Now, earlier it was error, and I'm going to just say debug. And if I go to console log, it'll start from debug. But then you can obviously change it to different views as you see fit, right? No errors, which is good, I guess. The third and the final feature that I would like to talk about today is something that I've implemented within the app, which I believe will expand its capabilities far more than I anticipated. This is the concept called hybrid connections. Now, let's look at a typical home network scenario, right? You've got a lot of devices in your home connecting to one of your Wi-Fi networks, which you connect out to the world. Now, there is a firewall that protects the network from external intrusions. The problem with such a setup is that legitimate requirements, for example, connecting your flow or your power app to your devices in your network will basically get blocked, and rightly so, because we do not want anyone to be able to access take advantage of the fact that you have opened up a port or your network out to the world, and with legitimate reasons. So there is a problem there, in the sense that your devices are unable to receive messages from outside world. So which means that your power apps and your Canvas apps or your flows cannot connect into your network either. But so how do you solve that? Because we definitely want to see our apps being controlled from outside. For example, you probably want to create a PVA bot, which basically where you ask a question to it to see what the status of a device is. Maybe you have a camera facing one of your rooms, and you would just want to see what's happening there by simply putting messages up in Teams and through PVA and through Flow, you would want to connect your Raspberry Pi and see and take a snapshot from your camera. Now these are all legitimate reasons for having the firewall allow the connections to come in, but it is not good to just keep all of your firewall open or even a port in your firewall open. So what do we do? We do with something called hybrid connections or Azure relays, as we call it, right? Now, this is the same principle that on-premise data gateway uses, wherein your apps within your home network through your firewall connect to a well-known source like Microsoft Azure and Microsoft Azure relays, and because you're connecting out, the problem with the opening of ports disappear. How and the fact that Power Automate and PVAs and Canvas apps can actually talk to Azure means that we have a nice clean way of getting data in and out of your home network, right? But we need to do some configuration there. And one of the first configurations that you need to do is to set up the hybrid connections. No, just because you got a hybrid connection set up in Azure doesn't mean that you got the right to access it. You need to create a key. You need to create a shared access, key with specific policies set up so that you can, your app can connect to the relay and keep that connection going. And Azure can send you data. Now, on the other side, in your Power Apps and Canvas Apps world, the Power Apps and Canvas Apps will need a shared access token, similar shared access token or shared access signature, to be able to send data to the network, to your home network. So that way, there is quite a tight security loop going on there. But the problem obviously is that generating the key is not straightforward. If you were to go into Azure portal, set up your relay, and you set up your shared access keys or your shared access policies, you will find that there is no way to create a shared access signature token from the portal itself. So which means that you need to do some clever things with encrypting data, adding an expiry time. All of that needs to be done somewhere, somehow, so that you can create that. So for that purpose, what I've done is I've created a generate key within the app, which allows you to specify a shared access policy name and its key, and specify how long do you want the key to be alive in days. Then it'll generate a shared access token for you. Once you've generated a shared access token, then you can send messages to it. That is one aspect of it, which means that from the infrastructure side, you can do this, you can set it up in this way, but then you obviously need to know how you need to be able to write flows which allow you to react to those messages coming back from Azure. So for that purpose, I've added a new type of flow called web request flow, and I've already set it up. For example, here is when the fan status is requested. So this is one of those where you want to see whether the fan is on or off. The other is you want to switch on or switch off the fan. Now, I won't go into the details of it. We'll cover the details of it in a different video. But bear in mind that this particular path or this particular piece of text is what will become a part of the URL which you can connect to. So here is the API endpoint specifically for sending messages to your fan, right? Now I can copy this URL and I can basically go into your Power Apps or Canvas apps, and generate a token and then go there and then use it to send messages out to the world. Now I have not prepared a Power App for this demo. I will do that on a different day. However, what I have done though is I have tried to experiment with Postman. I don't know if you've seen Postman before. Postman is a great API testing tool. So what I'm going to do is before that, let me show you how a shared access signature looks like. So it looks like similar to this. And when you use the generate key option within PyFlows, you are able to generate the shared access signature. once you generated it, you can copy and paste it here, and then you can continue to use that. So here is one. So what I want to see is if the fan is on or off. So I'm basically going to send a message to my flow to see if the fan is on or off. It basically says low. So what if I switch on the fan from here? And now if I send a message back, you can see that it says high, which means that the fan is on. Now, how about controlling the fan? So you can send a message. You remember that the messages, I had already configured this. This is the URL. And this is not, you can also notice that it's not a local host URL, unlike the app. It is actually a URL to an Azure relay that's been configured, which a particular, you can see that here when you see the services.windows.net. And then I'm sending it through to Azure so that it reaches my Pipeflow. So what I'm going to do is I'm going to basically switch on the fan, or actually switch off the fan. So let me try doing that, right? And you can see that the fan is off. Now, what if I switch on the fan? What if I send a message to switch on the fan? There you go, the fan is on, right? So this is how you would typically manage this. Manage to connect from external services to your Pipeflow. So that's one of those features that I have added, and I'm basically that is the list of features that I've added to the app this week. I will see you next week with something more. Cheers, bye.